Hey everybody, today we have something a little different to look at. Something that I actually saw for the first time on another YouTube channel that I like to watch. There's a link down in the description to them, and hopefully I remember to edit one of the corners. There's a channel, Tank Masters Environmental, family company out of New York, who does oil tank removals and soil remediation when an oil tank leaks. And they have a really cool channel. Surprisingly, they don't have a ton of subscribers, which I don't get. But if you don't subscribe to them, give them a click. It's they put out content fairly regularly. Brian, the guy that runs it, super nice guy, very interesting. You go beyond just the oil tanks, but anyway, enough going on about them. The point is that they use a device for checking the soil for volatile organic compounds using a device called a PID meter.
Craig and Mike are getting the sample from the bottom of the bucket, and we're going to get a reading. Looks like 80 is our highest, so not that bad.
This should be actually the same model that they use, or at least one of them. It's made by PerkinElmer. This particular device was made in, I think, 1998. And so I'll be curious to see what sort of guts it has. This is the sticker from the eBay seller that I got it from, so I'm just going to peel that off because it's kind of in the way. But you can see it has two LCD displays on it. One that will list the volatile organic compound amount, and then some other functions down here, memory and whatnot. There's supposed to be a calibration gas that is used with these. It's isobutylene, I believe. But there's no battery with this one. There's no gooseneck. There's supposed to be a little gooseneck straw that comes off. Like, there's a whole setup, and you can buy these for, fully functional for anywhere from $500 to $1,000 depending. Sometimes cheaper, sometimes more. But I got this one pretty cheap because there's no battery and there's no other power supply or anything. This DIN plug down here is actually used to connect to a printer. I looked up the manual on it, and it's pretty cool. But let's go over the outsides before we start opening it up to really see what's going on inside. I do have a way to power it up, so we will be powering it up to see it do things. Hopefully some isopropyl alcohol is enough to trip the sensor. We'll see. The way it works, a quick overview, is there's a little air pump inside that sucks air in through the front. Behind this cap, there's a particulate filter right here. And that particulate filter, you can see it goes over top of that washer. Then the sample's pulled in through that hole. I'm leaving the filter on just because I'm keeping it all together, and I don't want to draw any crud into it just in case. So after the sample is sucked inside with the air pump, it's passed through two metal plates which are inside this cavity here. Inside this cavity there's a UV light source. The UV light is projected, shines through the air path that the sample is going through, and that UV light causes the volatile compounds in there to become ionized. Once they become ionized, the two metal plates that they're across can conduct some electricity across those plates through the sample. This is going through air. The amount of conductivity through the sample across those two plates is what dictates how much of the sample gases are in there. So if in the situation that I see this used, the guys are looking for heating oil that leaked into soil. They want to see when that amount of heating oil has dropped below a certain threshold, depending on where they're doing it. So they'll take a clump of dirt with that they want to sample. They'll start with an obviously contaminated sample, and they work their way down to the uncontaminated, or as least contaminated as possible.
We've removed the tank, cut it in pieces, looking for our start point. So we just took our scoop right here, as close as we want to go to the foundation. The tank grave was over here, but we took a scoop at the bottom. We got some gray, which you know is the contaminated soil. You see the gray all the bottom of there. So now we're doing a PID reading. About 103. So we know that's our start point, right at about 6 feet below grade.
And it's looking for, heating oil, diesel oil fumes, basically. So those oil fumes get sucked in, they go through the tube, they go through the little plates on the inside of the UV light, and that diesel fume becomes slightly conductive when the UV light shines through it, and becomes conductive enough that the two plates can measure the conductivity of that oil gas sample. PID stands for photoionization detector, or photoion detector, depending on where you read on the internet. But that's what it's doing. It sucks the air across the plates. The sample changes its conductivity depending on how much is in that, because of the UV light. The UV light makes that happen, and then it measures it and displays it on the screen. If you have the other kits, you can have it print out your readings. You can probably dump it to a computer. This is 1998, so it's not a USB type thing. They probably had some fancy expensive dongle or something you had to buy. But I don't know, the fact that they're still using these is pretty good. So let's just do a little external tour before we open it up. I showed you the filter behind the front cap. Normally there would be a NiCad battery pack in here. I think it's 7.2 volt. That would plug in here, and then there's a battery cover that goes over it. Then you have your charger port for the battery pack, or to run it, I guess that would work. There's a charge LED here. There is a speaker behind here, and then that's the air exhaust, so that when the air is pulled in and run through the sensor, it exhausts through there. Then we have the sensor / lamp area here. The lamp is pretty interesting. It's actually the first time I've seen a lamp like this. That little spring comes out, that helps hold it in place. And then the lamp is this ampule looking thing. PerkinElmer PhotoVac. It's a 7698. I'll look that up, and if I find any info on a 7698 PE UV source, I will put some info in the description or up on the screen or something. But as you notice, there's no electrodes. I believe there's gas in here, and that gas is excited by some high voltage, probably in the bottom. Then it grounds out through here, I'm guessing, but I don't see any connections there either, and that rubber washer seems to indicate that this just seals up. So the spring's pushing down on that to hold it in place. I even have a little picture on the back to kind of show you. So that little tube emits UV light and shines through the sensor pack down there. Actually, let's see if we can see the sensors. Let's take that out, pretty sure I don't want to touch the face of it. So there's the grid array down there, the target. There it is down the bottom. So that's where the gas actually goes through to be ionized and measured. And that's probably also how the UV is activated. And I'm not sure on that part. That's the only part I'm not really sure on, is how they energize this lamp to make the UV. But it's probably something to do with, you know, high voltage around it. So anyway, let's get inside this thing. We'll take the straw adapter off, and I'm just going to push the filter inside there so I don't lose it. Then there's only a few screws. One, two, three, and four. And then those two. And that's it. That's all that's holding this together. Now, I've actually had this apart once just to kind of familiarize myself with things so that I didn't bumper around and fumble too much. But when I first took this apart, the LCD panel, there's our first view of your first view of the inside. This panel was sticking to here, and it pulled up and out, and a bunch of the legs that go into those sockets were actually kind of bent. So I think somebody else had it apart before me and didn't put it back in right. So I reseated everything and it was happy. But here's our first view. This is what 1998 technology looks like, or earlier maybe. Oh, we need that. I'm going to save that washer, or that O-ring. There's the ROM with the software, PhotoVac 2020 version 1.17, September 4th, 1998. So that makes this 24 years old, this particular device. And the electronics are pretty good for 1998. I know we had surface mount back then. It wasn't super uncommon, but some of the parts definitely are higher end, like that capacitor there, for instance. So anyway, let's do a quick tour of what I have figured out so far. That's our serial port, I believe. Charger port in here. And what I did, and we're going to actually see this soon, is I soldered little loops on there, and so I can connect it up to a power supply and we can drive it and see what happens. So it looks like power. This is probably the charger for the what do you call it, for the NiCad. Over here, what do we have? We have this. This is a piece of, I think it's high voltage coax. And the way it's connected over here, it does make me think that it's high voltage, and it also runs over and it runs into the detector tube. Oh, to get that out, we have to take this out. So we're going to lift the this out after I take the screw out here. And after we look at everything, I'll put it kind of back together, and then we'll fire it up and see what happens. As I thought about, one of the reasons I wanted to look at these was to see if I could repair them, because I'm always looking for new things to learn how to fix. Probably hand assembled, definitely machine built, but hand assembled. It's a lot of test points. Look at all those test points. Probably calibrated in the factory. You can see that's where the battery would plugged in right there. And then as we move up, here is the pump. This is the air pump that pulls our sample in. That's where the sample goes in through that hose. You can see it goes into that detection chamber here. And then that hose goes into the whole thing, so the air is pulled in like that. And then through the pump, and then exhausted out through there, so it goes like that. It's pretty, this part is pretty straightforward and basic. There's not a whole lot going on. I think this is a sensor. This must be a light sensor to tell it when the UV source is on. It only has 2 wires, so my guess is it's a photocell of some sort. Let's unplug it. Then let's pop that whole detector assembly off. Unplug the pump. Then we'll unplug the, yeah, that's high voltage. It's probably doing negative high voltage, would be my guess. Like a, oh, I don't know. I think I read 125 volts negative on some of these as a common voltage used. Let's get the ground off too. There we go. I'm just going to set that here. So this is the, that's the detection thing. Now, I don't know if that opens. Doesn't feel like it. I don't know why that would be so heavy. Let's see, does this open at all? No. I think there just might be something in here to... Let's see. It doesn't want to open. There might be a transformer in there. I don't want to wreck this thing. I want to be able to keep using it. I see these 2 pins here. They go into something. That might be for turning on the UV tube. I'll bet that has something to do with it. Let's actually look at that connection on the board here. Those plug into there. Like that. It just says J2. It doesn't tell us anything about it. Maybe we'll put a meter on it when we fire it up. Let's see, can I get a better view? If I pop this clip off, can we see the detection grid? Now, if I do wreck it, it's really not that big a deal. Like I said, it's just for, I got it just for the sake of this video. Oh, but it looks like I don't have to wreck it. It looks like we can actually get a good view of the detection grid. So the air comes out through that hole in the center. And looking at the way this is made, the negative high voltage, oh, we can see it. You can see how it's layered. Negative high voltage is the closer one, probably the grid that we're looking at. And then the ground, which I think was this side, is going to be the other plate. And then the tube sits right here, like that. So the tube is probably excited, it glows its UV light, and then causes the gases to be ionized, the sample gases, and then measured. So that's the whole measurement assembly right here. So I'm going to actually put that back on. Oh, I see more. Okay. We have an electrode there and an electrode there. So I'll bet you that's for the UV light. I'll bet you those 2 electrodes are for the UV light. This is probably a transformer in here. It's, I mean, it's heavy. So it's definitely doing something. Okay, so that goes this way. These go here. Just trying to get this back together properly. Come on. There we are. Alright, so that is back together. So that could go back in. Here's our little pump. It is a Schwarzer Precision 5-volt. That's pretty good. That's a neat little pump. If I end up ever scrapping this thing down, that'd be a piece I'd keep. So I got the meter. Let's see how many ohms, if any, that transformer is. You guys can see that? Yep. So let's go across. $296.6K. That could be right. Let me just make sure that these are definitely not connected. Yeah, they're not. So I think that those pads in here probably are the other side of this. Let's see if this sensor is anything. So we're getting nothing. Wait a minute, there we go. So about a meg. And does it change if I cut the light off? Oh yeah. So that's probably a light sensor. Where's my flashlight? Let's really exploit that and see if that's the case. I think that sensor in the bottom is to tell it when the UV light source is on. So let's hit it with some visible light and see what it does. Down to 1.2K with that visible light. So if we turn it off, it goes up to meg. Wow, that's a really wide range sensor. So 1.1 meg to 1.1K using a flashlight. So that's what that is. That is a photocell of some sort, that thing right there. I'm not going to pull it out. It's kind of glued in there. So let's put this back on here. You can see those two holes. That lines up. And then let's see, our high voltage goes there. And then the ground wire goes here. Here we are. Let's just bring that all back down. Make sure those pins are still lined up. There we are. Let's snap back down. Let's get our pump plugged back in. And there's a whole bunch of electronics. I know what all the electronics do by themselves, but I'm not really sure which circuit is which. There's a microcontroller under this display, which is probably just for driving the display. This is probably doing everything. I expect there's most of it's being done through this. That's a LM6001, and I'll put up on the screen what that is. It's probably an op amp of some sort, instrumentation amp maybe, and that's probably a A to D converter, I'm guessing. Max 713. So that's some sort of communication. So there's probably some analog to digital converters in here. This is clearly power stuff. And then I'm sure there's things for controlling the motors and the lights and stuff. I don't know if that pot there is for adjusting the high voltage or what. Just don't know. I suspect the high voltage is being made by these two transistors, though. So, anyway, let's put the tube back in. Let's put the cap back on. Actually, let's put the cap back on after I set it back in the bottom, because we're going to fire this thing up. I want to see this thing run. Let me just wrap that back around there to help manage that wire. And then we're going to put that, so plug that into here, and then we'll snap the pump back into its bracket, rotate it so it's in the right place, like that. Just set all this stuff in, run that tube where it needs to be. There we are. Come on. There we go. Had to get it down all the way. Alright, that's good. Now I'm going to put that screw down in the bottom. And then I'm going to get my portable battery power supply here. I use this for powering anything up to about 20-25 volts using DeWalt drill batteries. I can either run 2 batteries and get up to about 24 volts, or run 1 battery at a time. These are getting near the point where they're going to need to be charged, but for this they will run fine at the 7.2 volts that we need. So let's get on the ground. And let's get on the power. Let me just make sure that's safe. And then let's set our voltage. Let's go to 7.4. And we'll do about 1.5 amps. Alright. There we go. It's got power to it. So let's hit the on button. There it goes. Is that not enough power? Yeah, not enough power. So maybe it needs a little more voltage. Let's see. Let's go to 8 volts. Oh yeah, there it goes. So it's getting 2.6. Alright. Come on, off. Alright, let's just turn that off because it's a little annoying. Get it back down to, I'm going to run it at 9 volts. I'm not really sure what the battery voltage was. I thought it was 7.2, but clearly it's not. Let's get some, see if some isopropyl will, if anhydrous isopropyl will trip this thing and make it pick some up. So I just soaked that swab there. Let's turn our battery pack on. Let me move my needle nose out of the way. And let's see what happens. Look at that. So we're getting about 2.5, but if I hold the cotton swab near the tip and it starts inhaling basically that isopropyl, that's tripping the sensor. And if we take it away, we can see it goes away. So, exit. Set. Clock. Pump is off. There we are. Okay. Let's exit. So, now I think we can start over. So let's see, how do I tell it to go? Enter. Set. Pump. Pump is on. There we are. And it's drawing about 150 milliamps at 9.3 volts. So it seems like it's kind of many systems working with each other instead of one system, because it seems like the rest of the device stays on when you have it working off the pump. So it's probably always measuring. I don't know what that LED's for yet. Let's see, if we go to here, we can almost get to go over 100. Can we get, I don't want to touch it. It's alright. You get the idea. So, this thing's kind of neat. I'm going to keep it. I'm going to figure out a way to power it, maybe lithium batteries or something. I'll get a new connector and maybe I'll 3D print a cover for it. But it's kind of cool to have a, something that you can use for detecting volatile organic compounds. It doesn't tell you what those compounds are, it just tells you if they're there. Say I want to weld or cut an empty propane tank. I could, have a little tube coming off the end, stick it inside the tank, run this, see what it comes up. It'll tell me how much propane's in there, fumes and whatnot. So that's kind of handy. So, yeah, I will maybe do a follow-up on this if you guys have anything that you want to see specifically. But I think we're going to wrap the video up here. If you have any questions about this PerkinElmer 220 PID meter, go ahead and stick it down in the comments. If you want me to fix one, I don't know, I'm thinking about trying it. Let me know if you have any questions or if you have any ideas or things that we could try to do with this. I'm curious to learn more, maybe do a little bit more reverse engineering on it, I don't know. Just thought it was a neat device, and I thought the Tank Master guys kind of turned me on to some cool gear. So I want to make sure I give them a good shout out. So a link to their channel's down there. Go give Brian a subscription. He's at like 600 and some now, and he really should be at like 6,000 and some. So go down, give him a hand. Hopefully they enjoy seeing this video. And as always, thank you for watching.